Welcome to Our Earth Rising, a podcast by students and faculty from Texas A&M University. Our podcast aims to spotlight each of our planet's ecospheres and to discuss the complicated, challenging, or wicked environmental problems found in today's globalized society. In February 2021, Texans experienced what was seen as a rare weather event, a snowstorm in Texas. During this episode, we will explore how the atmosphere influences and contributes to large-scale weather patterns. Our team will then take a deep dive into what happened during the winter storm in terms of both climate change and the impact on the Brazos Valley community. We will also look at why our most recent freeze was not as extreme as what we saw last winter. To gain some background information about the atmosphere, our first guest, Dr. Rodrigo Bombardi from the Texas A&M Geography Department, joins in a conversation with our team member John Morgan to discuss the ins and outs of weather patterns.
I'm Rodrigo Bombardi. I'm an assistant professor in the Geography Department at Texas A&M. I'm originally from Brazil. I did my undergraduate and my master's in meteorology, and then I came to US and did my PhD in geography. Worked the East Coast for a little bit and joined Texas A&M 2017 as an assistant professor.
Awesome. Thank you. Can you tell me a bit about the work you do?
Sure. I'm mostly focused on rainfall in the tropics. So I focus on understanding what causes variability in precipitation, mostly in developing countries because they happen to be, tropical regions. I study mostly things on seasonal timescales and longer. And I try to understand what causes variability of precipitation and how can we improve our prediction of precipitation, and also a little bit of climate change, how climate change affects tropical precipitation as well. A lot of my work focuses on understanding the timing of the rainy season over tropical regions.
Is there anything about climate that you would want to impart to just a normal Texan, somebody who lived in Texas, about like how global climate works or these large climate systems? Maybe something that when you're teaching your classes, you're like, I wish that people knew this.
Well, when I teach my classes, I wish people knew the difference between weather and climate. That's the first thing I wish that they knew, right? So people say, climate change is not real because my hometown is cold right now. Climate change is not real because there's snow, and on the ground. And, a politician one time brought a snow to Congress, right? To make a point. And stuff like that. I wish people would get that climate is a long-term thing. You can think about, the surface of the ocean being like, a very long wave, and then you have the weather, which are the very higher amplitude kind of oscillations, right? That's the main thing I wish people would understand, that, climate change is something that is going to happen very slowly over a long time. And when you see a freak winter storm like we had recently in Texas, and that doesn't disprove the fact that climate change is happening, right? That's one weather event that happened to be very cold. And those things will still continue to happen, right? If I think climate change happened in the way that people expect it to happen, and then we just wipe us out, super fast. It's just like, because already is something that is too fast for for ecosystems and animals to actually adapt to, especially birds. But if it was the way people expect it to be, there was no hope for anybody on this planet, because that's one of the main things. Another thing I wish people would understand is like a little bit more about forecasts and what makes a good forecast and what makes a poor forecast. I think one time I was living in Virginia, and there was a forecast for snow starting at noon, and I left my office at 11 to go grab some lunch, I think. And this lady passed by me, and she looked at the sky. It was starting to snow, right? It was 11 a.m. And she said, "So much for starting at noon," right? And that is like a crazy thing for me to experience, because a forecast that has like 1 hour of error, and it did snow. It snowed 1 hour earlier than it was supposed to start. And that is an amazing forecast. But the lady was very upset because it started an hour earlier than it was supposed to, right? So there's the movie Back to the Future 2, when they go to the future, and their future is 2015, by the way. And in the movie future, they had a precision of a second. So the doc looks at the clock and waits for the exact second where the weather forecast was the rain was supposed to stop according to the weather the forecast, and it did. Right, we're not quite there yet, but at these days, I'm pretty sure for like 24-hour forecasts, you could get a precision of minutes nowadays. But if people understood what is a good forecast, if the forecast says it will rain and it rains at all, it is a good forecast, in my opinion, because these are very hard things to predict.
What do you think is the greatest kind of limitation for us right now in improving forecasts? Is it data availability, or understanding the processes, or computing power?
Oh, I think it's probably a mix of all of them. So if we had more data, we'll be able to understand processes at a finer scale, right? Because it's a trade-off between resources for high performance computers and our understanding of the climate system and understanding the processes, right? And data. So we know processes that we can measure up to a point, right? Up to a time of there's a limit in time and space that we understand processes, how processes happen. If we could have higher resolution in space and time for observations, we would definitely find other things in there, right? To describe. So when we represent, a cloud in the model, there's a bunch of physics and everything that goes into it that gets represented in a software, right? A model is just a software. And our limitations are also there. So if you don't know what happens on a fine temporal or spatial scale, it's not going to be represented in the model, right? But then at the same time, the model has limitations in terms of computer power, right? So if you run the model for the forecast for tomorrow, we need a supercomputer to make all the calculations in time, right? If you increase the spatial and temporal resolution in the model, which is possible, you need more computer power, right? So if you increase the resolution too much in time and space, you might get the forecast for tomorrow on 2 days after it, because it's how long it takes to make the forecast, right? So there's a trade-off there of how much we can do and how fine resolutions or how information in fine resolutions we can provide, and also limitation of understanding the physical world, right?
As we can see, the atmosphere affects our everyday lives and is constantly changing due to climate change. Some major events that accumulated due to these changes have affected us locally.
The week of Valentine's Day 2021, the temperature dropped below zero. Over 5 days, 4 million Texans lost power during what turned out to be the coldest winter storm in half a century.
There's a lot of sleet coming down on top of me. The road, the sidewalk, all covered in sleet.
We're talking about record-breaking cold temperatures. There are power cuts as the state tries to cope with a huge spike in demand for electricity. Despite its fame for oil, Texas leans heavily on wind power, but now many turbines are frozen solid. Millions have been without power.
The fire department rushing to the scene here on a report of heavy smoke coming from a generator. The power has been out here, and it's evidence of how this catastrophe is unfolding in so many ways. Hundreds lining up for much-needed supplies as officials here tell residents with power to boil water.
How can we boil water? We don't even have power.
We have been without power for 60 hours now and without water for about 24.
My family and I, we've been in the dark since Sunday night.
For Alex, this must feel like the perfect storm. Heavy snow, no water, no electricity, and a baby due now.
I think she's maybe instinctively kind of holding back on having the baby just so we can maybe have power and water and roads can be a little bit clearer to get out. But yeah, definitely unnerving as we've gotten closer to the due date.
His family has stocked up on food and supplies. The habits of the past 12 months now reaping a dividend.
It's a lot kind of like what we've just gone through with the pandemic. You're kind of without services, you're without places to go. So to a certain extent, we're a little used to it.
The power to a number of homes here in Texas was restored overnight, but still so many people remain in the dark. And between the electric issues and the water, guys, this is far from over for so many people here in Texas.
To discuss the weather events that led to last year's winter storm in the southern United States, specifically Texas, one of our team members, Austin Begin, spoke with Dr. Nielson Gammon, the Texas state climatologist. Along with his work for the state, he is a Regents professor at Texas A&M University with focuses in applied climatology, extreme rainfall, drought monitoring, and local circulations.
Hello.
Howdy, how are you today? Welcome to the podcast, Dr. Nielson Gammon. Go ahead and give an introduction.
I'm John Nielson Gammon. I'm the Regents Professor of Atmospheric Sciences at Texas A&M University, and I'm the Texas State Climatologist. I do work on applied climate, including droughts and floods and extreme weather of all sorts. I've been at Texas A&M for a little bit more than 30 years. Grew up in California and went to school in Massachusetts.
Alrighty, our first question for you today. The cause of the VorTexas event back in February 2021 has been attributed to the polar vortex. Is this a correct assessment? If so, can you please describe what the polar vortex is and how it was able to reach as far south as Texas?
Well, the polar vortex is basically a mass of cold air surrounded by the jet stream that is typically found at high latitudes, obviously, because it rotates around the pole. We tend to think of, in atmospheric sciences, we sort of separate out the polar vortex and the stratosphere, which is where the term normally is referred to. And then it's also been applied now to stuff lower down in the atmosphere where you've got a particularly cold mass of air. The story, I think, starts in the stratosphere when the stratospheric polar vortex, which is normally fairly steady, except for every 2 or 3 years it sort of breaks down and splits. And this year it broke down and split during January. By the end of January, basically, we had the polar vortex sitting well off the pole, and that was contributing to a flow of cold air across the pole from Siberia, across the Arctic Ocean, and into northern Canada. So that's step one in the February cold event. Step two was the creation of a fairly large wave in the jet stream down here in the troposphere, which included a big ridge over Alaska, so that the jet stream didn't actually cross the Pacific coast of the United States anymore. It actually moved north into Alaska and then down southward parallel to the Rocky Mountains. And that allowed the cold air in northern Canada to move southward into southern Canada and cross the border into the northern United States. And as part of that, the polar vortex in the troposphere, a piece of that came down with it and ended up sitting over southeastern Canada for several days and basically kept the cold air locked in place in the eastern half of North America. Then the last straw was a weather system that did manage to sneak in from the west coast that wasn't strong enough to move the cold air back northward, but gave it an extra kick at the end behind it to bring the cold air southward across Texas and into the Gulf of Mexico. And we've been cold before that. We'd had the ice storm in Dallas Fort Worth and the chain reaction traffic accident back on February 11th. So the cold air was already there, but the super cold air needed that last push from that last snowstorm. And so as with most extreme events, it takes this sequence of events that aren't individually all that unusual, but if they happen in the right order, in the right place, at the right time, you end up with something that is out of the ordinary.
So looking back now, is this something that the state has seen before?
Well, on the one hand, we never see an event that's an exact repeat of a previous event. Certain aspects of this have happened in the past. For example, I mentioned it was pretty unusual for widespread snow, but there have been a few like that before. But the ones that most closely resembled this one were in if I remember right, 1895, 1921, and 1929. So it's been almost a century since the last snowstorm hit Texas that was this big in terms of hitting all portions of the state at the same time. In terms of the cold, it's also a top 5 event. Not so much in terms of the lowest temperatures reached. We've had some pretty impressive cold fronts come through Texas that really drop temperatures low. The most recent cold spell that would be comparable to this was back in 1989. December 89 had cold weather for several days, like this one. A little colder in most places, milder in a few. For prolonged cold weather lasting 7 to 10 days like this one did, you'd have to go back to 1983 to find an event that was comparable to or stronger than this one. And again, some places this one was worse than 1983, but 1983 overall was probably worse. So we've now talked about 3 aspects of this event. The widespread snow, which is not unprecedented, but top 5. The intensity of the cold, which is not unprecedented, but in the top 5. And the prolonged nature of the cold, both not unprecedented, but probably top 2. Put that combination together, the other events that beat this one out only beat it out in one of those categories. So the combined cold and snow and persistent cold was indeed unprecedented, at least as far as back as we have weather records in the state of Texas.
The winter storm that happened in February 2021 had a very interesting analysis for extreme weather patterns. Now, let's take a look at how this event affected us locally. One of our team members, Nathan Woodfield, met with Jennifer Nations, the City of College Station's Water Resource Coordinator, to discuss how weather events like this impact local utilities.
I'm Nathan Woodfield with Our Earth Rising podcast, and I'm sitting down today with Jennifer Nations from the College Station, Texas Water Department. In regards to the actual storm that we had back in February, what caused so many boil water notices during the week of winter weather and the following days?
Yeah, it was pretty dicey. I remember watching before things even really got bad. I remember watching that weekend. There was a utility kind of near here. I think it was Mahia. There was a small water system that had a boil water notice, and they had some equipment fail, and they just could not provide water to their customers. And then they just once the freeze really took over Texas, the utilities just started falling. I can't really speak to specifics of other utilities, but I can speak on what causes when certain conditions are met. The Texas Commission on Environmental Quality requires a utility to issue a boil water notice. So, for example, what happened to some of the utilities is, there's any event where conditions at a public water system are such that public health protection is compromised or potentially compromised. So low pressure, water outages, disinfectant residuals below the required minimums, line breaks or repairs that you can't isolate, storage problems, well problems, mechanical equipment problems, power outages, treatment facility problems, natural disasters. So when some of the utilities around Texas they found that they had no power, then they may have hit the conditions to have to issue a boil water notice. Other utilities had things like the power outages or the well problems. If there's a surge, it's if a motor on a well burns up, and your utility only has one well, like if you're a really small utility, then basically if your utility has no means of supplying water to your customers, then that fits the criteria that TCEQ puts out for a boil water notice. Or if you have low pressure, so if you are not filling and maintaining your elevated storage tanks, then that would be a condition of low pressure. And that's what some of the utilities experienced.
Well, thank you for that. Is there a policy in place that allows for the exchange of water resources between College Station and Bryan?
Mm-hmm.
Okay, do you mind elaborating a little bit on that, please?
Sure. And we've had those interconnects in place for a number of years, and we've, each utility has helped out the other. Usually it's something like in the summer, if one utility has a well go down, and they may have high water demand, then another utility can supply the other one. So it's something relatively minor, pretty simple, pretty simple transfer. Again, with all of the utilities, both locally and statewide, experiencing the exact same crisis at the same time, it made the response especially difficult. But we have the interconnect capabilities, and we have agreements. So that really helped us minimize the local impact of the storm. And so because of that, it got a little confusing, I think, towards the end, where we have the city of Bryan and its drinking water utility, and the city of College Station and its drinking water utility. But then there are the other water utilities surrounding us that serve some customers in each city's city limits, and they were under boil water notices for a time, but the city utilities were not. And so that was a little confusing, but I think we all came through it as best as we could.
Now we have heard how changes in climate can impact individuals and the local community. As we have heard, there are some weather patterns that are indicative of what we can expect, which raises the question, are these patterns going to occur more often? And can we expect to see more events like this one in the future? To discuss what we can expect this coming winter, our team member John Morgan followed up with Dr. Nielson Gammon.
After talking with you previously, we discussed how weather patterns over time influence events like the polar vortex last winter. But can you tell us what we should be expecting to see this winter, and potentially what the impact of the La Nina conditions of the El Nino Southern Oscillation might be?
La Nina conditions are when conditions in the tropical Pacific are a bit cooler than normal, and that tends to make the jet stream be a bit farther north than usual. And as a result, we tend to be relatively warm and dry during the wintertime on average. But the Arctic regions tend to be cooler than average during a La Nina. And so there's the capacity for very cold air to occasionally make it down to Texas. We actually had a weak La Nina last February or last winter. And most of the winter, except for 1.5 weeks in the middle of February, was warmer than normal. So that's the sort of thing that can happen. We certainly don't expect a repeat this year because it was unlikely last year also, but it's certainly within the realm of possibility.
So for really extreme events like this, these global teleconnections like ENSO are really important.
Generally, if you have something extremely rare, you've got to have lots of things lining up to allow that to happen. And at least based on some of the evidence I've seen, it's probably much more likely to get one of these things during a La Nina than an El Nino because it's one of the dominoes that basically falls into place. But a lot of other things have to happen too. So, you never know what's going to happen in a particular winter, but it certainly changes the odds a little bit.
Awesome. Thank you.
The atmosphere of our Earth holds vital information about our history and future here on this planet. With the help of experts in this field, we can continue to understand more about its complexities and how it is interconnected with our daily lives. As we've heard, something as simple as driving your car to work plays a role in changing our climate. This concludes our episode on the atmosphere. We want to give a special thanks to Dr. Nielson Gammon, Mrs. Jennifer Nations, and Dr. Rodrigo Bombardi for agreeing to appear on the podcast. If you enjoyed listening to our conversation, we encourage you to share the podcast with your fellow Earthlings and consider leaving a review. Next episode, we will be covering Earth's lithosphere. Before we sign off, we would like to take this moment to highlight our social media channels, where you can receive updates about the podcast, learn more about our guests and their research, as well as explore deeper topics related to Earth's environment and ecospheres that we just cannot fit into one episode. You can follow us on Facebook and Twitter at Our Earth Rising, and on Instagram at Our Earth Rising Podcast. Be sure to also subscribe to our YouTube channel titled Our Earth Rising Podcast for extended interview clips and more. As mentioned at the beginning of our episode, the Our Earth Rising podcast is created and produced by a team of students and faculty at Texas A&M University. The speakers and interviewers for this episode were John Morgan, Austin Begin, Paige Fawn, John Adams, and myself, Sydney Pearson. Thanks for listening, and until next time, keep rising.